Test, mic check, mic check. Good morning, ladies and gentlemen. Morning. We're about to start in like 2 minutes' time. So if you have any friends who are outside, can I get my volunteers as well to help me call everybody in? If you have friends who are outside, who are at the booths or taking pictures, please ask them to come in. And we're going to be starting in just about 2 minutes' time. All right. Are you guys excited? Yeah, all right. I'll get the energy levels up with a quick icebreaker later, but I'll just give 1 or 2 minutes for people to come in. I know nobody's actually listening to me. Everybody's just looking at my hair and wondering whether it's a real one or a fake one. I know. This is something that even zkEVM cannot understand. I can assure you it's real. Don't worry, I'll talk about my hair a bit later. I hope all of you are excited. We've got a lot of interesting things happening up. Let's just give some time for those who are outside. If I can get my volunteers to help me pull them in. We've got a few more people outside. We'll just wait for them to come in, and then we'll be starting very, very shortly. Okay, those of you at the back, don't be shy. You can come in front if you want to come a bit closer. We're also going to take a nice big group picture later, so we're going to fill up the front seats as much as possible. Okay, I'll see you guys in a few minutes' time. Continue chit-chatting with your neighbor, and we'll be back soon. All right, ladies and gentlemen, I can see most people are here already. I think maybe just a few more outside. They'll be making their way in shortly. Good morning once again. Good morning, ladies and gentlemen. Good morning. I love the energy. We're going to build it up just a little bit. My name is Ross. It's a pleasure and honor to be your MC today. The first time I MC'd for ETHKL, it was virtual. We were doing everything virtual during COVID, so I'm very happy that we get to do a nice, big physical event. In fact, this is the first Ethereum conference in Malaysia. So give yourselves a big round of applause. Indeed. You guys are going to be a part of history. We also want to extend a very warm welcome for those of you who have traveled from outside of Malaysia. If you are not from Malaysia, can you please raise your hand and give us a wave? If you're outside of Malaysia, let's give them a big round of applause, Malaysians! Thank you guys for joining us all the way from the front to the back. From whatever country you're from, we want to welcome you very warmly to Malaysia, and we want to make sure that you feel right at home over here. All right, thank you so much for joining us wherever you came from. A quick house rules. I want everybody, if you could please help me, just silent your phone. So if you've got your phone with you, I always make sure audiences do this at the beginning. Please make sure you take out your phone and just put it on silent mode if possible. We don't want to interrupt any of the speakers later during the ceremony. Yeah, please silent mode. Or if you're taking videos and pictures as well, please make sure you switch off the flash. Now, today's very special event is first Ethereum conference. We want to make sure you get lots of pictures, lots of videos, and please don't keep it to yourself. You must share it with everybody. So put it on Twitter, Instagram, or whatever social media that you use. We really want to spread the word and bring more people into conferences like this. All right. Let's do a quick icebreaker to get everybody a little bit more loosen up a little bit. So wherever you are in your seats, I won't make you stand up yet. Can you all just roll your shoulders with me? Roll your shoulders. You know, all of us, we sit down for 8 hours a day. You have to roll your shoulders. Can you do some stretches to the left? Yes, you stretch to the right a little bit. We roll our heads, roll our heads, roll our heads. Yes, very good, very good, very good. Now, everybody, can you raise your right arm? Raise your right arm. And can you wave it, wave it, wave it, say hi. Hi. Say hi, lah. Say hi. Hi. Okay, wave to the person on your right and left. Say hi. Hi, hi. You look so good today. You look so good today. Tell them, you look so good today. If you've got boyfriend, girlfriend, please tell them first. Okay. Everybody give me an okay sign. Give me an okay sign and say, okay. Okay, very good. Listen to my instruction. No, hold the okay, hold the okay. Listen to my instructions very carefully. Bring the okay close to your face, close to your face. Put it on your chin. Where's your chin, ladies and gentlemen? Chin is down here. Ah, that's why. Listen, later we got a lot of important speakers talking about all sorts of developments and amazing things that are happening in the world of crypto, blockchain, Web3, Ethereum. So please make sure you pay attention and have a lot of fun. All right, let me just go to our first slide. Oops. Okay, so, sorry, excuse me. Before that, I just want to mention that today's event is really not just an overnight event. It is something that ETHKL has been running 5 years in the making. So ETHKL is a community-run a group of people that just gather a lot of builders, developers, students, adults, anyone from wherever you are welcome at ETHKL, and they run very regular monthly meetups all over PJ, KL, Subang Jaya, and they really welcome the community as everybody is welcome to build together, right, on Ethereum and the world of crypto and blockchain. And so they've been running for 5 years, and they've been very successful, so to the point that today, this year, they get to launch our very first Ethereum conference in Malaysia. So we're really proud of them. We're really happy to have them with us. Let's give them a big round of applause. You know, building a community is never easy, and in the world of crypto, Web3, blockchain, community is everything. If you don't have community, it's really tough to build. But we are building a really good, honest community. And what I particularly love about this community is that when you come here, nobody talks about when moon or what's the price. Nobody talks about that. There are only two things that you should be talking about today. What are you building and how can I help? So later today, when you're networking, you go and talk to your friends and people outside, just ask them, what are you building? How can I help? Okay? I also want to point out something fun today. I've never had this before, but if you can see this little piece of wood and this little string here stuck to my jacket, I can't take it out. There is a guy, he's Boki. Where's Boki? Can you wave your hand, Boki? That's Boki. Boki actually goes around all the Ethereum conferences, and he's here today to put this little puzzle around your shirt or your strap, and I can't take it out. I have a master's in education, but I can't take out a piece of string. So anyway, if you want that little puzzle to be with you, please go and find him later outside. Or I thought it was really cute and something to remember this conference by. Okay, without further ado, we've only got a short period of time here. I'd like to welcome our first keynote address. Can you please put your hands together for the organizer of ETHKL, Mr. Harit Kamarot. Ladies and gentlemen, let's give him a big round of applause. Without him, ETHKL wouldn't be here today, so we want to give him a big, big round of applause. And Harit, the stage is yours. Take it away.
All right, thanks, Ross. It's very hard to top Ross. I'm going to do my best. So the first slide here, before I start, I just want to say thank you to Faiz. I don't know if he's here. Raise your hand. Everybody wave to Faiz. Created an amazing sticker. If for the Malaysians here, it's inspired by Lat and shows our nasi lemak and some of our iconic buildings. It's also provided in your tote bags and also as a POAP. So if you haven't scanned yet, please do that outside. And yeah, it's surreal for me to stand here in front of you guys today. I still remember the days when it was maybe 5 people standing around a table. And today we have hundreds of people. We have 800 signups total. And yeah, it's thanks. It's crazy for me to be able to experience this. And thanks a lot for everybody for your support for making this happen. When we say Ethereum Kuala Lumpur, I want to take a couple minutes to talk about Ethereum and Kuala Lumpur. These are two things that I love dearly in my heart. And a lot of people ask me, why Ethereum? Why not Web3? Why not blockchain? When we do meetups, they're like, you know, if you have blockchain, you can cover a lot more people, you can get a lot more sponsors. But to me, Ethereum is a special thing. And it's not because I'm an Ether maxi and I care about my bags, but it's because Ethereum has carried over the torch from the early Bitcoin days, where all of the innovation, all of the smartest people are hanging around the Ethereum spaces. And you have the kindest, smartest, most sharing people who are sharing their knowledge and their love with everyone. And this is what we've been trying to do for the last 5 years in ETHKL. If you've ever been to our meetups, if you've ever been to DevCon, there is this, I like to call it a magical air that's, a magical vibe that's in the air, because if you go there, you have all these smart people and you don't even realize that they are some celebrity in their niche and they are happy to share with you all their knowledge. And that's something that we're trying to replicate as much as we can in KL. I believe we've done a good job so far with our meetups, and today I'd love for that to be scaled a lot more to everyone who is in this conference. So if you've ever been to DevCon, if you've ever been to ETHKL, please try and kind of share that magical air so that everyone can experience it and be able to share it with other people later on. Next is Kuala Lumpur. KL, it's, I'm one of those people who grew up in KL and always complaining about all the stuff that's happening here, always comparing it with cities outside. And it's only when you've gone to other parts of the world that you realize KL is an amazing place. With all of its idiosyncrasies, all of its potholes and traffic jams, it's something that is unique, that doesn't exist anywhere else in the world. I have amazing people, amazing food, amazing culture. And for the Malaysians here, please extend that Malaysian hospitality to all of the visitors that we have and all of the other Malaysians here as well. And one key thing that I want to highlight as much as I can I get the organizers who I'm showing on the screen to stand up? Yeah, don't be shy. Please take a close look at these guys. They are, please keep standing up, by the way. You're not done yet. They've spent the last 6 months of their lives, all the blood, sweat, and tears, all the drama that keeps happening even today, to make sure this thing runs. None of them are event organizers. All of them are doing it as a side thing on top of their day jobs. Yeah, we can't afford to pay you money, but hopefully at least having some social recognition provides a little bit of reward for what you've done so far. Thanks a lot for all you've been doing. And this is just the start of the weekend. We're not quite there yet. It takes a lot more effort to make this thing successful. And from the organizers, the volunteers, the sponsors, everyone here, please help to make this event as successful as possible. This is a community-run conference, without professional organizers. So we're quite maybe loose and might not be the best at certain things. So please kind of bear with us if there are any issues, and please feel free to give any feedback and help make the event as good as it can be. And with that, we also have this amazing Ethereum sculpture, if you haven't seen, on the ground floor. And please take photos of it and take photos and videos everywhere today. And if you can, put hashtag ETHKL23. We want the whole world to see that KL is an amazing place for Ethereum builders. And it takes all of us to be able to make that happen. Thanks, everyone.
Let's hear it for Harit, ladies and gentlemen. Thank you very much, Harit. Very inspiring indeed. It's not easy building a community. It's even harder to build a community that is so willing to volunteer their time, work for free. I'm also working for free, but I wouldn't say no to an airdrop. I'll just give you my address later. But anyway, speaking of free, before I forget, I forgot to mention earlier, please go outside later and collect your POAP tokens. Yeah, for those of you who might be new, POAP stands for Proof of Attendance Protocol. It's just like a sort of a digital badge. It's like a digital badge. It's just next to the registration counter. If you didn't notice it earlier, you can scan a QR code and you can collect it as a memento that you attended today's event. Yeah, so make sure you go and get that later. Completely free, don't have to pay anything. It's not easy building a community, especially in the winter markets, right? It's really, really quite challenging. Crypto winter, bear markets, nobody's that interested. But it's always so nice to see so many people coming out for conferences like this. In fact, as he mentioned earlier, I echo, it was about 800 people in total, from participants to volunteers and all that. And all of you are part of the first Ethereum conference in Malaysia. So please be please be very proud of yourself. Please be very happy, because this is something that is going to, I believe, just going to snowball and become bigger and bigger every single year. Now, ladies and gentlemen, coming up next, we're going to hear from someone who's a very influential person building in the space since 2011. I work in security operations in the world of crypto, and we need a lot of very highly developed tools to help us understand the blockchain, check for transactions and all that. And there's one place that I go to check all of this, and that is none other than EtherScan. So ladies and gentlemen, from EtherScan, let's put our hands together and welcome the CEO and founder, Mr. Matthew Tan, ladies and gentlemen. This man built EtherScan. Let's go.
Thank you, Ross.
You're very welcome.
All right. Good morning, everyone. My name is Matthew, and I'm the CEO and founder of EtherScan. So EtherScan is one of the longest and oldest public independent project built around Ethereum and for Ethereum. It is built by Malaysians and out of Malaysia. And it only makes sense that we're also one of the longest, strongest, and steadfast supporter of the local ETHKL movement. So ETHKL is all about the community and the values that Ethereum embodies. Their goal has always been to build a community of learning, sharing, and also to introduce the various Web3 stacks, but while still maintaining a unique Malaysian identity of humility, harmony, and diversity. So my own crypto journey started right here in KL, or as Ross wants to point out, it was actually in Kotak Maning, Malaysia in 2011. So it's been 12 years, right? So nothing too fancy. So I was surfing online, and I came across this, if I recall correctly, this Hacker News article that talked about Bitcoin. So that kind of got me intrigued. I started researching it more. And the more I looked at it, the deeper I got into the rabbit hole. So now, the very early days of the crypto community in Malaysia, let's just call that the 2013 to 2015, the pre-Ethereum era, pre-ETH era, right? Started with very small informal gatherings with folks normally meeting after work or on the weekends. So, and getting together at mamaks, kopitiams, coffee shops, cafes, and just about any makan or what we call eatery places to talk about crypto and to share their passion. A much smaller crowd back then. And if you ask me back then, looking at today's larger gathering of like-minded Web3 folks, it's amazing how much we've grown. I was always fascinated by the concept of smart contracts. And in 2014, I worked on building the early versions of token-based Bitcoin explorers. But it was difficult back then because Bitcoin really wasn't ready for smart contracts. And the real game changer, that came in 2015. Boom! The Ethereum network was launched. I was excited and I felt like I wanted to play a part, no matter how small it was, in supporting the community and ecosystem. But I obviously could not do it alone. And along the way, I found other like-minded folks to join me on this journey, who today make up the team at ETHKL. So I think deep down on a personal level, we also wanted to show that as Malaysians, we could build global products. Now, I think if this was outside of Web3, this would have been a much more difficult task, building it out just of KL as opposed to somewhere in Silicon Valley. But because we're building on Ethereum and Web3, where the access to data and ownership is decentralized, this is not a blocker anymore. It's an equal playing field. Together with other companies building out of Malaysia and the many others here today, right? We've shown that it is possible to build global products out of Malaysia. So anyway, coming back. So the idea of ETHKL was actually thrown about in 2018, and like-minded folks like Harit and the OG team back then put together the first ETHKL meetup. So that first inaugural ETHKL meetup was done in 2018. Yeah, you can see Harit there, which I had the opportunity to participate in. It was smaller, but with an equally passionate group of like-minded folks. And fast forward 5 years later today, with more than 150 events organized, and just looking around at today's crowd for ETHKL's first major global conference and hackathon, we have indeed come a very long way. So wrapping up, lastly, a special shout out again to the ETHKL community and organizers for their hard work and dedication in putting together this Ethereum non-profit event, and all the amazing speakers, sponsors, and the Ethereum Foundation for their support. So over the next 2 days, I hope everyone here has an awesome time, not only learning about Ethereum and Web3, but to also take this opportunity to network and engage with like-minded individuals. I say Malaysia boleh to my fellow Malaysians, and for those visiting Malaysia, selamat datang. Take it easy, chillax, and enjoy yourself over the 2 tracks for the 2 days. Thank you. So one last point. Whoever wants like cookies that look like this, right? Please find for my colleague over there. So we have about 100 of these left. Thank you.
Ladies and gentlemen, let's give it up for Mr. Matthew Tan. Thank you so much, sir. Welcome you back to your seat. All right, Matthew is truly a builder at heart. I say this because in the past 5 years, I've only seen him in real life twice. But he only comes out for the most amazing events. So we really appreciate Matthew coming out and sharing as well his journey about developing one of the biggest, well-known, recognized brands in the world of crypto, right? ETHScan. Every day, we all depend on ETHScan. Without ETHScan, it would be so much harder. So really appreciate the work that he's done, the team that is building each and every day, right, to make the life of developers and also other people a lot easier, right? So that's the whole point, right? Coming together to build and make the world a better place. Now, ladies and gentlemen, our next speaker unfortunately could not be here physically. He's overseas, I believe, in Istanbul right now. But we've got a video recording, so let me quickly just introduce, ETHScan. Okay, thank you, ETHScan. Yeah. All right, so our next speaker is actually Skylar Weaver. He's the DevCon and DevConnect lead in the world. So for those of you who may not be familiar, I'll just give a quick background. So DevCon is actually the largest Ethereum-based event that happens in the world, right? Everybody comes from all four corners of the world to come and go to DevCon because it's really like top tier event. Now, Skylar is actually the DevConnect lead, and he's going to be in charge of deciding, I believe, the venue for next year. Now, he has hinted that next year is going to be in Southeast Asia, all right? But we're going to change that to Malaysia, okay? So now, again, he could not be here, but he has blessed us with a little video. So we're going to play a video, and he's going to be addressing all of you in the video. Let's enjoy it together.
Hello, everyone. My name is Skylar. First and foremost, I want to say sorry I couldn't be there with you all in person. I would have loved to join you there in Kuala Lumpur, but I'm actually currently here in Istanbul preparing for DevConnect, which I think some of you might be coming to in a few weeks. Harith asked me if I could make a quick intro or a quick greeting to all of you at ETHKL, and I said I would love to. So maybe as a little bit of background, my name is Skylar. I work with the Ethereum Foundation, specifically on the DevCon and DevConnect teams. And one of the reasons why I would be so excited to talk with you all today is because DevCon. For those of you who don't know DevCon and what DevCon is the global Ethereum community reunion. So I will actually share a screen with you. I'll share my screen here. And yeah, DevCon is essentially the main event that the Ethereum Foundation organizes, and it's our biggest event. So we do 2 events per year. We do DevConnect, and we do or 2 events in general. We do DevConnect and DevCon, and DevCon has been our oldest running event. The first one was in 2014, and essentially it has rotated around the world since then. So we can see even here at past events. We can see that DevCon 0 started in Berlin in 2014, actually before the launch of Ethereum. Afterwards, it went to London in 2015, DevCon 1. DevCon 2 came to Shanghai in 2016. DevCon 3 came to Cancun in 2017. That was actually my first DevCon, where I participated as a volunteer, just a volunteer. And that's what got me into the whole ecosystem of Ethereum. DevCon 4 then took place afterwards in the Czech Republic, in Prague, in 2018. DevCon 5 took place in Japan, Osaka, in 2019. And DevCon 6 just took place last year after a little bit of a break because of the pandemic in Bogota. And so it essentially travels around the world each year. And next year, we're excited to announce that it's coming to Southeast Asia. We don't yet know which city it's coming to in Southeast Asia, but we are quite excited for it to come to Southeast Asia. And specifically, it's planning to come to Southeast Asia at the end of 2024. So in Q4 2024, that is public in Southeast Asia, but we do not know yet where specifically. But who is DevCon for? And so I would say DevCon is basically an event for the entire Ethereum community, for the global Ethereum community, to reunite, to collaborate, to learn, to share ideas across domains, and to advance the ecosystem. And so it's for everyone from top researchers to app developers to web developers who are working still in Web 2, to economists, to game theorists, maybe cryptographers, community builders, But really, anyone who wants to learn more about Ethereum is encouraged and welcome to come to DevCon to become immersed in what is a 4-day event, but like a week long of like unofficial events all around Ethereum and the many things that are happening within it. So it covers things from the protocol itself to layer 2s to developer infrastructure, governance and coordination, like DAOs and such, and much more. And yeah, and so we're excited to be bringing DevCon to Southeast Asia next year. And one of the questions we get asked a lot is why Southeast Asia? So why would we bring it to Southeast Asia specifically? And really, what we see in Southeast Asia is a lot of interest, a lot of massive, genuine adoption, and a lot of opportunity. A lot of opportunity for impact and for genuine use cases of Ethereum beyond just the simple trading and financial aspects of crypto that most people associate with crypto. And why do we think that? Well, one reason and one data point is Chainalysis released this report this year, just in September, about a month ago. That is the 2023 Global Crypto Adoption Index. And one of the things they noted was that Central and Southern Asia are leading the way in grassroots crypto adoption. And it's true, and it's very cool. So if we see here specifically in just Southeast Asia, within the top 10 countries, 4 of them are from Southeast Asia. So number 3, we have Vietnam. We rank in here. Number 3, we have Vietnam. Number 6, we have the Philippines. Philippines over here. And number 7, we have Indonesia. See if I scroll down. And number 10, we have Thailand. And so just in the top 10, we have 4 of the countries in all the world that are from Southeast Asia. And that's quite cool. That's quite impressive. And I think that's a big bonus for the region at large. And while Malaysia doesn't necessarily make the list of top 10, I think Malaysia comes in at 37 technically. And these scores are based on metrics around everything from like centralized exchange usage to decentralized exchange usage, to number of peer-to-peer exchanges, to DeFi and actual on-chain protocol usage. So it tries to combine a bunch of different, centralized aspects, but also on-chain aspects. Who's actually using non-custodial solutions and using DeFi to do certain things. So here you can see again Vietnam, Thailand, Philippines, Indonesia as high-ranking Southeast Asian countries. And while Malaysia doesn't fall into that list specifically, Malaysia, what you have is some advantages in the sense of you have one, some really important entities that exist in Malaysia, some really important companies. So one of those is obviously Etherscan. Etherscan is probably one of the most important and most used tools in the Ethereum ecosystem. And it's super cool and impressive that they're based in Malaysia. And I applaud all of the work they do to help to really support the ecosystem. I think they give it back in a lot of ways. And yeah, they're based in Malaysia. Another really great crypto focused team based out of Malaysia is CoinGecko. And more than just these companies, though, I think one thing that Malaysia really has going for it is an awesome community, namely ETHKL. And more recently, I think ETH is starting to start up. And quite honestly, they set the bar, they set the example for many communities around not just the region, but I would say the world for what equality community looks like, what quality education looks like, and what selfless community organization looks like. So I would say you all in Malaysia have the advantage of having a great community there and being in a region that has a lot of adoption and a lot of interest in general around crypto and crypto usage. And so So yeah, ultimately, we think that there's a lot of genuine potential and opportunity by bringing DevCon to Southeast Asia. We also haven't it's never been to Southeast Asia before, so it's the first time that it will come there, and we're super excited for it. So yeah, I would encourage everyone to stay tuned to the DevCon Twitter and things like that for what's to come next year. And I'll end with saying, I guess, that like we all have high hopes for Ethereum. I think you've probably heard some talks already, or if not, you will hear some talks at ETHKL around what it means, what we hope to achieve with Ethereum. And there's a lot. I think to different people, there are different objectives that people try to achieve with Ethereum. And it's everything from, I mean, I think personally that Ethereum is the next version of the internet. I think we're working on the next version of the internet. I think Ethereum will become core rails for the next generations of applications, the next generation of identity systems, of financial systems, of organizations, probably, aka DAOs, the next generation of property rights systems, and much, much more. And ultimately, I also think that we are extremely early. We're in the I would say the 1990s of the creation of the internet. And back then there was a lot of uncertainty in the world about what was the internet. It was generally quite inefficient to use the internet. It was slow, it was costly, they had dial-up, and there wasn't a lot to do, right? And so I think that's kind of the stage in which we are right now with Ethereum and Ethereum development. And I think very soon, over the next 5 to 10 years, the world will realize as we improve the protocols, as we improve the applications that live on these protocols, and the world will realize what really the potential of Ethereum is, and it will become obvious that this is really the next version of the internet, and it will have a lasting positive impact in the world. And so yeah, I guess I'll end with saying that I hope to see you all at DevCon next year, or on the road to DevCon. So I'll leave these QR codes here. On the left is the DevCon Twitter. If you're interested in staying tuned to DevCon and the updates there, you can scan that. And on the right, we have something called the DevCon Road to DevCon Grants Program. So here I will show you quickly the Road to DevCon Grants Program. It's a program to provide small sponsorships and monetary grants to meetups and educational initiatives happening in Southeast Asia. So if you are a community organizer and you're interested to learn more or to organize Ethereum meetups in your hometown in Southeast Asia or home city, then I would suggest you check out the Road to DevCon Grants Program. The technical deadline is actually end of October, but some alpha for you all is that we will likely be extending it. And so, yeah, check out this program. We want to hear from meetups, from university clubs, workshops, hackathons, grassroots communities, and we'd love to help grow the education around Ethereum around Southeast Asia. So the grants are up to $1,000 per meetup and per event, and you can submit it here at this form, which is which you can actually access at this QR code. It should be devcon.org/grants, or scan the QR code here. And yeah, I hope to see. I guess first of all, have fun in ETHKL, learn a lot. I think you're lucky to all be there in Malaysia with an awesome community, an awesome group of organizers, and props to them for putting on this awesome event. I wish I could be there. And I hope to see you all in Southeast Asia at some point next year on the road to DevCon or during DevCon, wherever it may be. So have a good one. Cheers. See you later.
All right, wasn't that amazing? Thank you, Skylar. He couldn't be here with us, but still a really, really great video. Let me skip. All right. So I think it's very nice and it's very reassuring, the fact that someone from DEF CON can compliment Malaysia in terms of the brands in the crypto space. You know, we even have hackers in the audience who I know personally who are winning championships around the world. So it's really quite amazing. I think Malaysia really is going to be one of the next crypto hubs in the next few years, and we definitely want to move ourselves from place number 37 to top 10, okay? So everybody tonight, please open 10 new wallets and invite all your friends. You know, we want to develop the space definitely in our country. And I can say, you know, I used to work in Luno, one of the regulated exchanges, and we work very closely with the SC. And there's actually a lot of grants, not just from DEF CON, but even from the government side that is actually promoting the development of things like this, right? Digital development in Malaysia. So I actually did not know about the DEF CON grant. Malaysians, please take note, please go and apply for the grant, okay? As much as possible. Even if you're not a coder or developer, you can organize meetups just like this, right? Just make sure you've got the right mindset and you can definitely apply. I just want to highlight the numbers here. We just want to highlight again that there are so many people here contributing, all as volunteers to their time, and we also want to thank all of you as participants for joining us, right? Again, this really is history in the making, the first ever large-scale Ethereum conference in Malaysia, and we're very proud to have all of you here with us. Give yourselves a big round of applause, you know? You're part of history, so that's always very, very nice to see. We're a bit tight on time. Let me quickly go to the next slide. Okay, let me just click manually. Can you help me? Thank you so much. I think just move the mouse, maybe it went off. Okay, let's do a quick thank you to all our sponsors. Okay, I'm going to read out the names of all the sponsors and we give them a big round of applause. Our gold sponsors are Aleo and Mantle. Our silver sponsors, I'mToken, Taiko and MDEC. Our bronze sponsors are AngelHack, CoinGecko, Ethereum Melbourne, Luno, Nethermind, Privacy and Scaling Explorations PSC, they're under Ethereum Foundation, Revolution, Scaling X, Starknet, and our venue sponsors, 42KL and Sunway University. Let's give all our sponsors a big hand. Thank you so much. We really appreciate it. You know, no event can succeed without the backing of really, really generous sponsors. So we appreciate each and every one of you. And most of them actually have booths outside. You can even talk to some of their members who are here and get to know more about what their companies do and what they're working on in the space. Just a very quick overview. So you can see JC1 at the top. That's where we are. So this is the main hall where I'll be emceeing as well. So JC1 is here. Outside, you can find the booths, Mantle, Aleo, and the other booths as well. Now, there are two other places. So don't think that this is the only venue. There are actually other venues where we're having simultaneous sessions. So you're going to have to look at the agenda later, which I'll display, and you have to choose which one you want to focus on. So there's JC3 just across, and there's also JC2. I think JC3 is workshops, yeah, hands-on workshops. So if you want to learn some stuff at the workshops, please go and check that out as well. And then, let me see, anything else? Okay, the rest all is just, everywhere here in the middle is a place for you to chit-chat. So if you want to have conversations, we encourage you to please go outside and find a space. Please don't have your conversations at the back of the hall, because when the presentations are ongoing, we want to make sure everybody's 100% focused on the speakers. If you want to talk, we welcome you. Just find a place outside. There's lots of space around the university. Now, I'm also going to very quickly go to the, okay, so it's not shown here, but for those of you, for our Muslim friends, if you need to use the prayer room, the Muslim prayer room or the surau, it's actually downstairs one floor. And it's on that side. So just go over that side, downstairs one floor, you'll find the surau in the corner. Toilets are located on, if I'm not mistaken, if you exit on that side, on the right side as you exit the hall, on the right side towards the end of the corridor, you can find toilets on each and every floor. For lunch later, okay, there's going to be lunch later. Lunch is going to be on the ground floor. I believe you have to go this side, downstairs to the ground floor. You look for a place called Fresco, Fresco, Fresco. Now, I want to give a quick disclaimer. When the event was being planned, they were targeting about maybe 400, 500 people. In the end, we were about 800 people in total. Some of them will obviously be coming in and coming out later. So when you go for lunch later, lunchtime is from 1 to 2 p.m. Do bear with us. We may not be able to fit every single person in the lunch hall at the same time, right? So if you see that the lunch hall is full, we invite you. There's lots of other places to go and eat, which are very within walking distance of the university. In case it's full, please again do bear with us. This is a volunteer-led event, and the venue just doesn't have the size and the capacity to fit everybody. But we're so wonderful to see, what a big turnout we have. Please make other arrangements if you notice that the lunch place is a little bit full. We really appreciate that. Okay, quick rules, okay, don't litter. This is a very eco-friendly campus. We want to go green. And they've also kind of like banned plastic water bottles. So please don't use any plastic bottles. Use your refillable bottle, okay? There are refilling stations all around the outside area and nearer to the toilets. So please, if you didn't bring your bottles today, no worries. Bring your bottle tomorrow, okay? But don't bring the plastic bottles. Sunway wants us to reduce that as much as possible, okay? Please be friendly to one another. Smile, turn the person like, hi, you know, talk to them, get to know them. You know, the reason why I say this is because these events are not just here for you to sit and listen, sit and listen, sit and listen. It's for you to network. We've got some of the greatest minds, some of the biggest brands, companies, projects, protocols, which are here today. So don't miss out on this opportunity. This is the place where you get to network, where you get to build connections, relationships with so many amazing projects. Really, some of the best minds are all here today and tomorrow. So don't miss out that opportunity. Just smile and get to know others, you know. In fact, today's event is actually so in demand that yesterday on Telegram, people were asking, where are the black market tickets? Because we sold out, right? They were asking, black market, I want to buy. I was like, wow, that is quite incredible. Okay, phones on silent mode in the halls. Please respect the speakers. And if you're taking pictures, please make sure you switch off the light. Yep. Chat and network outside of the halls. Stay hydrated, drink lots of water, take care of your belongings. So don't leave anything behind. Please pick it up with you and take it wherever you're going, your laptops, your bags, and make sure you got your hardware wallets all put nicely. You know, I hide mine in my hair. Nobody can find it. It's just like this, you just put in the hair, cannot find, right? See, magic. Anyway, and before I forget, I just want to again emphasize, please bear with us because we are at overcapacity. You know, some of the halls may not be huge, right? So please bear with us in case you may not find a convenient place to sit. You can always find a place to stand at the side, or if the hall for lunch is a little bit full, please make other arrangements as well. We really, really appreciate it because again, we're just here as volunteers. We're here to bring the community together. And if you see something that you can help at, please go ahead and help, okay? We really appreciate that. And don't forget to post as much as you can on social media. Tag DevCon, tag ETHKL, and tag as many people as you can because we want to bring the attention to Malaysia. We want to make Malaysia the next big place for crypto. Okay, let's take a group photo together. All right, we're going to invite our cameraman and we're going to take a lovely group photo with everybody. I'll also take a photo with my selfie camera. I think we can fit most people in. We'll take one, see if I can fit everybody behind my hair. I think can. Okay, we'll do one with my camera. Everybody smile at the camera. Smile. Okay, nice. I'll post that on Instagram. Can we get my photographer? I think my photographer is it. Yeah, okay. Okay, we got one over here. Yeah, okay. We'll try and fit everybody as much as possible. I'll stand next to the photographer and see whether we can get everybody in the shot, or I might need you to just stand up a little bit. Let me take a quick look. Can is your... You want to use phone? Can okay, come. No problem, no problem. On iPhone 15. Pro Max. Oh, can get raw. Okay. Can we fit everybody? Wow. Can the side might be a little bit. Okay, side edges. Okay, those of you at the front two, you can come in the middle. Can you come in the middle? Just very quickly, squeeze in. All right, very quickly, just at the side here, just the side. Down here is fine, yes. In front of the first row. That's fantastic. Thank you. Those of you all from here, just come just very quickly. You can come just in the front here, you can just take a quick meal or just sit on the floor if you don't mind. All right, yes, okay, much better. Okay, the last guy on the right side, you have to come in. Yes, let me see this side. Okay, you might be cut off a little bit. If you want to join the picture, just lean like that. Okay, can lah. I've got to come in also, yeah. Okay, can Okay, I'll come in. I don't want to block people with my hair. They always complain at the cinema, you know, cannot see the movie. Okay. Okay, everybody smile. We're going to do a video and we're going to say ETHKL 2023. Okay. So everybody, we're going to take a video. When he says 3, 2, 1, we say ETHKL 2023. Okay? You can raise your hands if you want. ETHKL 2023. Okay, good. Okay, thank you very much, everybody. Thank you very much. Okay, don't go yet. Quickly scan these QR codes. Okay, scan these QR codes. Okay, so our agenda, again, like I said, we've got different rooms, different workshops that are happening simultaneously. So you're going to have to find your opportunity cost and decide which talks you want to focus on. Here, there's going to be some talks, JC2 some talks, and JC3 is going to be some workshops, hands-on workshops. So can you all please quickly scan the agenda? It's also on the Ethereum website as well. The ETHKL 2023 website as well. And after you got the agenda, I also want to highlight there are some side events happening today. Okay, so let me just quickly scan the agenda. Okay, there are also some side events that we want to highlight because the side events are going to be happening later in the evening. So if you want to check them out, they're going to be quite interesting as well. I think we've got about 3 or 4 side events. Come again? Okay, all right, so I'll let you all read through this in your own time because we're a bit short on time today. So please, I'll just leave it for another 5 or 6 seconds. Please quickly take a picture of it. The side events, when you go into the file, there'll be a Google Docs link, and then you go to the right side, and then you can sign up for the event. Some of the events are at capacity, but you can always just sign up and try your luck. Okay, there's one by, I think, MetaMask Builders Night. There's one by, you see, Starknet, I think. There's Ordinals Meetup, I'm Token Connect. So lots of stuff happening. They're happening in the evening after our session here, you know. So please make sure you go and check it out and go and attend with your friends. Okay, if you need any more information, you can always ask the organizers for more info. All right, we're going to be starting our sessions already. So ladies and gentlemen, if you already got the agenda from just now, this is JC1. We're going to be covering a lot of things about zkEVMs, rollups, layer 2s for today. And then tomorrow, we're going to be covering DeFi and other protocols as well. Okay, so please stay in this hall if you're interested to find out a little bit more about our speakers in JC1. If not, we welcome you to quickly go to your other halls. Please go now as soon as you can because we're going to be starting ASAP. All right, we're going to be starting ASAP. Our first talk today is going to be from Aleo. All right, so you want to find out more about this, please come and stay. We welcome you to also make your way forward. You can come in front a little bit if you want to hear and you want to see a bit up close and personal. Oh, careful when you're walking down the staircase. It's very deceptively. This hall. Aleo is going to be in this hall. Aleo is going to be in this hall. All right, so if anybody's interested for the Aleo talk, it's going to be in this hall, followed by many other talks as well, which we'll be announcing. JC2 as well, and JC3 is going to be the workshops. They're going to be simultaneous, so you're going to have to decide which hall you like to attend, yeah? Every single hall is going to be having something interesting. So I know it's going to be tough to make a decision, but try your best to just pick one. Tomorrow, we also got a lot of talks as well. And don't worry, even if you miss out on a talk, the speakers will be around. You can always come and chit-chat with them later. Okay, if you're making your way to the other halls, thank you very much. Please make your way swiftly and efficiently. We've got a very tight schedule. Each speaker is only have about 20 to 30 minutes to talk, so it's going to be very, very tight. But we want to keep it moving swiftly and excitedly. Yeah? After the speakers are done, you can always go and chit-chat with them later as well. Those of you who are at the back, I invite you to make your way forward if you don't mind. You can always come closer, no worries. Okay, I'll just wait another 1 minute for everybody else. If you're going to another hall, that's fine. If you want to stay in this hall, you are more than welcome to stay in this hall. Okay, we'll just wait another 1 minute or so, and then we'll start with our first speaker of the morning. Daniel, right? Nice to meet you, Daniel. Hi. Where are you from, Daniel?
Currently in Korea.
Korea, okay, fantastic. Validator ecosystem lead, Aleo advantage. Hey, sup for you. So Aleo is where is it based from?
I think most of the team is between New York and San Francisco.
Okay, cool. Is it built on Ethereum or is it a separate blockchain?
It has a separate blockchain.
Okay. Are your slides already? You should be. I hope so. Yeah. Okay, let me just check with him. His slides are there, right? Okay. The clicker. Okay. There you go. All right, ladies and gentlemen, we're going to kick off our first session today from Aleo Blockchain. Please put your hands together for Mr. Daniel Hwang from Korea, ladies and gentlemen. He's the validator ecosystem lead for Aleo. Yeah, it's on. Yeah, there you go. Take it away, Daniel.
Cool. Okay. Yeah. Hi, everyone. I'm Daniel. I help out with the validator and the ZK mining or /ZK proving ecosystem on Aleo. I'll just do a really quick introduction of myself. I used to lead the protocols team at Stakefish and led the special projects team at F2 Pool. So F2 Pool was the largest Bitcoin mining pool in the world, and Stakefish was the largest Ethereum validator, non-custodial validator in the world. And so I guess that's a good connection to Ethereum. And maybe my personal connection with Aleo is when I was studying cryptography in grad school, Matt Green was my advisor. Do you guys know who Matt Green is? No one? So Matt Green was one of the co-authors to the Zcash paper, along with Ian Myers, who was also a professor at one of my universities. And then they came out with a paper in 2018 called Zero Knowledge Execution, which was basically allowing smart contract privacy. And so a bunch of the co-authors to that paper, specifically Howard Wu, left their PhD programs and then started Aleo. Maybe the direct connection to the Ethereum ecosystem and broader ecosystems, I would say, are twofold. One is obviously the zk aspect is this scaling, the scaling that's been offered. But also, I think the second most exciting thing about these zk ecosystems is the establishment of a brand new infrastructure class. So if you're familiar with Bitcoin and the POW chains, you have POW miners. With POS, we have what are called validators. And just coincidentally, I had worked quite extensively in both ecosystems. And now with the rise of zk, we have a third infrastructure provider class called zk miners. And so it's quite exciting. It's quite exciting to be a part of this sort of brand new infrastructure sort of development. I think a lot of what these zk chains or zkL2s or zk ecosystems would say, beyond some of the scalability affordances that zk gives you, is that you have this sort of blue ocean opportunity. And then obviously POW style zk mining is the beginners benefit from it. So this is a pretty interesting slide sort of for the evolution of what we've been seeing in the crypto ecosystem. So you can see, I kind of broke it down into infrastructure classes that we've been seeing over the past 10 plus years. I myself I used to be a big Dogecoin miner and Bitcoin miner a long time ago, 2013. But so what we see is sort of this, not just the infrastructure class evolution, but we also see sort of the possibility for more, I guess, technology improvements. So what we have is these old Chom-based cryptocurrencies like DigiCash, Hashcash, and then Bitcoin was able to solve a pretty critical element in incentivizing good behavior with proof of work. And eventually, a lot of development had come there, and specifically with zk, we saw Zcash, essentially a fork of Bitcoin that allowed this privacy to be provided. And then, why Ethereum existed was this programmability aspect. And so with the rise of Ethereum and its transition eventually to POS, we have now validators, with this ecosystem. I think a very sort of rudimentary way of imagining some of these zkL1s or Aleo is that you have now the ability to have this sort of privacy and scalability layer with zk, to also have the programmability that you have with Ethereum and these types of smart contracts. And so I think maybe one way to think about it is, this is sort of the next domain of evolution for what is possible on this sort of technical infrastructure stack. Mind you, zero knowledge proofs has been around since the 1980s, and only recently have we sort of seen enough technological advances to make use of that in both mechanism design and hardware. And so I think one of the sort of side goals or side effects of this incentivization mechanism that cryptocurrencies and their associated blockchains provide so well is that you have this sort of hardware infrastructure that's being developed. Really quick anecdote is, like, I used to do bioinformatics research for about 6 years when I was doing a lot of distributed systems work. And we had used zk in the process of something called like fully homomorphic encryption, which is basically you can run computations on encrypted data. The problem that we had was that, let's say we had 6 different labs and we all wanted to share genomic data with each other and run computation on it, but we didn't want to give up our data because it was expensive. So like very specifically, what I did research was on human gut microbiome, and you get that from poop. It's very expensive to get human poop. And so what happened with the problem with FHE is that you have to encrypt the data before you can run computation on it, but then you don't have the ability to verify whether or not that data that you put in and encrypted is good data, right? You can just put trash. And so we had used zk to prove certain properties of the data that we had in order to put it in and have the peace of mind that we're not all getting screwed by each other. And so what we had to do is, at least in America, we had to write these lengthy National Science Foundation grants to be able to get enough money to run zk on the cloud. And so I think that is a small example of what's so exciting about now this sort of perfect storm of what we had seen evolve in the past with these infrastructure classes, notably what we have now with zk mining, that has the ability to give us sort of this marketplace of service providers that can kind of help people like me if it was 7 years ago. And so I think also, the interesting point of why cryptocurrencies exist is namely to have this sort of incentivization mechanism that now can be going directly to an infrastructure class that can be sort of getting paid for their work. And the direct example there is, back in 2013 when I was mining Bitcoin, we were all doing it because, we wanted to burn down the banks, et cetera, right? But the reality is that we all did it ideologically and we had no idea what Bitcoin's price would be. Nowadays, what you would have with Bitcoin mining and specifically when I was working with F2Pool, Bitcoin miners and the mining farms don't necessarily have to have that ideological resolve to sort of be participating in the network. They get paid for it. And so there's the very key point in how good behavior as designed by these systems has to be incentivized. And that incentivization allows these large companies like Bitmain to exist, right? Bitmain manufactures 90% of the entire world's POW ASICs for Bitcoin. And they're only able to grow so large and develop this very specialized hardware because they were getting paid for it, right? Bitcoin's rise in speculative value, value is what drove it. And so with sort of this idea of technology advancement that we had gotten to with the appropriate people who have largely contributed most of the seminal work on zero knowledge proof research, at least from the cryptography side, as we had seen with Matt Green, Ian Myers, Chesa, and the rest, and Howard. And we also have this ability of understanding how infrastructure does evolve. And the next step is sort of this programmability that we have with privacy with zk. And so I think personally it's quite exciting to me. Over the past 10 years, we've been seeing this evolve, and we're beginning to see sort of this work in effect. And so I'll describe some of this. I already described a bit of this, but we have this sort of this maxed out sort of scale on privacy and programmability, right? Ethereum was created because Bitcoin was not programmable enough. Zcash was a fork of Bitcoin that allowed privacy. And then now you have both programmability and privacy. And I obviously described some of the brief mechanism of why we need to have this sort of POW style proving mechanic for the zk proofs, and then some of the programmability that Aleo has provided. The explanation of some of these, right? So this unlimited application runtime is largely due to some of maybe like this sort of scalability features that many of you might be familiar with coming from like the L2 side or some of like the ZK side, is that you have this set of infrastructure providers, aka these ZK miners, or you could call them ZK provers, that can sort of like run this computation in a verifiable way. Obviously, right, if you want to get very technical or semantic about it, you're just like kind of moving the trust layer to another degree. And maybe to compare it to like rollups, specifically the optimistic kind, right? You have the trust in math versus sort of like this game theoretic trust in that someone will be able to capture some of that. I think one of the more popular failures or more popular attempts at sort of like the game theoretic sort of bounty hunter system that we've been seeing versus sort of like this mathematical guarantee through ZK is, if anyone's familiar with Polkadot, right? Polkadot used to have something called Fisherman, but Polkadot deprecated that away. And so you can basically run programs off chain that can be verified mathematically through ZK. Obviously, the caveat to that is you have to trust that the math is correct, right? But I really do think maybe one of the most unfortunate mantras that we've been seeing so often, at least in transparent blockchains, is this concept called like don't trust verify, where the burden is on the user to be able to sort of audit their own smart contracts if they're going to be interacting with it. I mean, I consider myself a pretty technical person, but I don't think I've ever like gone through and audited contracts before I use them. And I highly doubt that any of you have either in a serious way. And so I think that type of usability is right, like a way that we can kind of move forward in sort of move forward from false paradigms that we had crafted. So one specific example that you can maybe take away from this sort of unlimited runtime is, right, if you want to run like a machine learning classifier on data, perhaps on let's say the Aleo blockchain or any other blockchain, for example, and making use of this infrastructure class, these ZK miners or ZK provers, is that you can kind of have like these classifiers running these as long as you want, and all you need is a simple proof that can be verified quite easily by the appropriate stakeholders and operators on Aleo. I think I'll get to this slide in a bit, but yeah. So now I'm going to come back to the beginning of how a lot of this is crafted. I think a really very reductionist way of thinking about Aleo is it's like Ethereum plus Zcash, right? You have programmability with privacy, right? As we'd seen in this slide, right? Like Zcash has privacy, but it doesn't necessarily have the full expressivity of programmability, and Ethereum doesn't have privacy, right? And I think that's also probably one of the most problematic UX issues that we've had, aka, right? I'm pretty sure most people in the world don't use Ethereum or Bitcoin as it was intended, at least to guard privacy, where literally you're supposed to like create new addresses or accounts every time you send transactions. But everyone just has probably one wallet that they use to transact with everything. And so, right, I will know your entire net worth if you just have one account. So privacy is quite important. And so what we have is, and maybe for some of you who have been following Aleo for the past 3 years, Aleo used to be based on something called POSW, Proof of Succinct Work. It is now, as of this year, transitioned to a hybrid POW style / POS style ecosystem. And so the POW style part of Aleo is we have ZK miners, right? They run the proofs and they get rewarded for it through a Coinbase reward. And the POW style is basically the consensus and the block building that are done by validators. And if you're familiar with Aptos and Sui, it's the same sort of like consensus mechanism, bull shark, and the and it's narwhal for the transactions. Basically, it come from the DM and Libra team that Dalia Malki had set up, which was largely inspired from Rapid. Which, fun fact, I had used to do research with Dalia on Rapid. Quite old one, but and then yeah, Leo is the programming language for Aleo. One thing I would like to say about these, I guess what you would call domain-specific languages, right, with Leo is that, right, we've been seeing a lot of these interesting approaches to, right, these new sort of like, these new blockchains or these new languages. And the biggest complaint, I think, is that it's very difficult for people to migrate to a new language to learn it, right? And so like, okay, how are you gonna get mass adoption and developer mind share? I think I would say two things maybe that you could take away with it, or maybe two and a half. Well, I guess like the half is that, right, programmers should have the ability to sort of like adopt new languages, and I think it's quite trivial for those of us who have the ability to build new stuff with it. And part of that is that you need to have like this ground up approach to be able to make use of a technology that is not necessarily easily sort of like retrofittable, or I don't know if that's a word, but like backward compatible, let's say. Yes, you can make compilers that can like translate things, but I think it's important to understand that, right, for something as specific as zero knowledge proofs, and you need to have like the appropriate tools to make full use of it. My analogies kind of suck, but like I think one way I try to think of it with the necessity of DSLs for ZK is that, right, you can have you want to sit down, let's say, right? And then you can sit down on a table or you can sit down on a chair, right? Both would sort of like fulfill the use case of being able to sit, but then a chair has been literally crafted to allow you to sit, I guess, most optimally or most comfortably, versus sitting on a table that eventually, I don't know, your back will hurt, et cetera. But and something that's quite interesting, especially with regards to, let's say, the developer mindshare that people have concerns with this sort of like new languages, and specifically with Leo that has been built from the ground up by the team, and actually like Ian Myers had contributed significantly to it. Is that I think, right, and we saw a lot of this in the early days of Ethereum. Let's say as developers or even as like ecosystem potential partners or projects, you need to be able to understand that, right, the demand should drive the desire to learn these new technologies. There's like a long time ago, there's like some study that had said like if you can pay, for example, a developer or allow a developer to run like $70,000 a year on technology, they'll crawl through glass, right? And so I think that's important to keep in mind, right? And especially not trying to like FOMO you guys, but like, right, being early to technology and being a master at that craft and the ability to kind of like guide that to other people is quite fortunate, right? We saw Ethereum Solidity developers, even though those docs were quite trash in the early days, right? Charging like $300 an hour plus, right? Because there was so much demand for it. And like I think like the very small example that I'd given with the research I'd been doing in the bioinformatics field provides a really intriguing and compelling use case for ZK being allowed to be used in both Web 2 and Web 3, right? It's not necessarily just like a speculative use case. And specifically on that, like a way you can kind of wrap your head around it is, for example, like I started like one of the first climate working groups in crypto, and right, everyone hated on Bitcoin because they thought it was burning down the planet, and artists hated it, right? The fact is that the aerospace industry emits 9 times more carbon emissions a year. But then, right, the difference between the value add that Bitcoin had and let's say what aerospace travel has is that people, right, value aerospace travel, and then they didn't necessarily like destroy the aerospace industry. Whereas like there are different examples of people saying Bitcoin is valuable or Bitcoin is not valuable. I would say at least, right, just in general, not just Aleo, but like with ZK, it's such an exciting way of thinking about how you can provide these infrastructure service providers that will exist that can service both Web 2 and Web 3, and this sort of like engine of incentivization that is powering these, which is the example of like how Bitmain was able to get created from Bitcoin. And so I think that's incredibly exciting. So, right, someone asks you like, why ZK, et cetera, right? You have this immediate applicability into both Web 2 and Web 3, not just speculative use case. And so, yeah, this is maybe to get more into technical weeds, right? Like validators will host applications on a registry. Provers will run the proofs that you want us to mine. Initially, what you can think of is, right, is in the start of the network, ZK provers will mine Coinbase rewards. And one specific caveat or difference between sort of like POW style, let's say like Bitcoin mining, is there's no winner take all, right? You already have this sort of like, you know, quote unquote, enshrined into the protocol like a pool, right? So if you can generate a proof in a matter of in a fixed time period, then all the provers or all the ZK miners will share pro rata for that. And so you can think validators are getting a share of the Coinbase reward that the ZK miners are mining, and then producing blocks from that. Eventually, what I think is going to be quite exciting for ZK miners and provers that are created from like these zkEVM or L2s, when we need it, is that these ZK miners would also have this sort of opportunity as a service provider to service other businesses like, right, research labs like my own. Yeah, and so, yeah, I kind of gave this example of like game theoretic security versus mathematical security. And then, yeah, this is what you probably are familiar with in ZK. You can have these proofs that are running through this language and this specific virtual machine that the provers and validators will run. Yep, we'll have a program registry for our validators. Maybe something that's interesting about Aleo is you have the ability to sort of have this sort of backward compliance with some privacy. So, for example, right, let's say the South Korean exchanges, they don't like privacy coins, right? Or even like all types of exchanges, where if you want to send a transaction out of a centralized exchange account into a private address, you can't do that, specifically if there are custody issues, et cetera. And so, right, that gives a lot of problems to these privacy ecosystems that do have certain things at default, right? If you're familiar with like, if you remember like Grin with Mimblewimble, and then like certain, let's say like Monero. Right, versus like what we'd see with like Zcash, which is like public by default and you have to pay a bit more to be private. Aleo has this concept of like sort of like a view keys, where if you control this private key, then you can technically sort of decrypt transactions that you had that don't necessarily have, you can prove certain things about it, right? You didn't touch a North Korean account, for example. And so, right, that's not obviously, right, that's from that spectrum, it's very clear that, yeah, transparency by default exposes much more than you probably would be comfortable with exposing, and you can only use it in a limited way, versus privacy, and you have the ability to expose certain things like, let's say, the U.S. government comes knock on your door and says like, prove that you haven't been interacting with North Korea, and then you can do that. So it's very, very specific to how you want it. So I think that's something notable to have here. Yeah, you can have transaction execution here. So I think, and I went over some of the applications or possibilities here, right? I think one of the thing, and you guys can just like take a picture of this, but private stablecoins that can be compliant with specific opportunities for people to reveal things without revealing it to the entire world, right? Private dexes or dark pools, I think, if you've been familiar with like Ren and what they were trying to do. And then you also have like, I guess what's really popular these days, like zkEVM. I think one thing I would like to say about zkEVM or like a takeaway is that, right, with machine learning, you need to have more data to have effective models. I think the trend nowadays is that people are wanting to withhold their data, and so it's difficult. But then if you can like sort of like provide information and data and then protect it or prove certain things about it in an encrypted way through zk, then you'll have more data coming to that. Yeah, so yeah, I'll just leave this up. But one thing I would leave is that Aleo has a bunch of grant programs. Obviously, every project has grant programs. We have 3 different types. One is it goes from ignition, launch to blueprint. And then the ignition grants are around like 5K. The launch grants are up to 100K. And then the blueprint grants are 200 plus. And I think what's the most interesting or exciting, at least from my end, is like the infrastructure. And then I think that's a really great opportunity for you to be build some infrastructure tools, right? You want to be Etherscan, be the first Etherscan. Though it does require you to understand the way that these systems work. And there's bug bounty programs. One other thing that I think would be interesting is sort of like the ability to have some more of this tooling be developed, sort of more distributed globally. And so it's why we're here in Southeast Asia. And obviously there's been a history and track record of a lot of fundamental infrastructure that's been developed both through like Etherscan and like stuff like CoinGecko. And yeah, take a picture at some of these. If you go to the GitHub on the bottom, that's some examples of programs that Howard, the CTO and the founder have created. You can go to an online IDE like the play.leo lang. And then you can also, right, I haven't written here, but explore.aleo.org, you can kind of see like what's been going on in the test nets. And yeah, last 2 things is validator testnet is happening end of October to guiding up to mainnet, and mainnet is launched in December. So yeah.
All right.
Thank you.
Ladies and gentlemen, let's give him a warm round of applause. Thank you, Daniel, for sharing a little bit of an introduction about the Aleo protocol. Very quickly, does anyone from the audience have a question they want to ask? You can just raise your hand. Privacy is always... Oh, you have one question over here. Let me pass you a microphone. Just give me a second. We don't have much time, so I'll probably take one quick question. All right. Okay, so introduce quickly your name and just a short question to Daniel. Thank you.
Hi, Daniel. My name is Alvin. Our team is currently joining the hackathon, and we are building on Aleo. One of the challenges we face right now is that due to the nature of the architecture of the entire zk circuit, programs cannot share state between each other. So will this, let's say if we created something, let's say an ERC20 token in a program, it cannot be, the record probably cannot be consumed by another program to do other stuff. So will there be a workaround for this, or will there be any further developments that you can share with us on Aleo?
I think maybe, so there's like a project internally that Aleo has been creating called ZPass that sort of allows you to be this sort of middleman or middle layer that both humans or even businesses and then projects want to have and how they want to interface with sort of some of the state. We also have quite a few validators that are familiar with sort of building this infrastructure and architecture on other chains, and some similar other ZK projects that have been building like scanners or indexers. And I think there could be a way. I think something that would be interesting is maybe also take a look into like past projects that I think are interesting to like share data between each other, or like sort of delegate that. I don't know how familiar you guys are with, remember like NewCipher, but like, right, there's like this concept called proxy re-encryption that allows you like sort of pass keys and delegate that if people want to use it, right? NewCipher, Mitch, he was the guy who created Curve, but after he left. But I think that's a pretty cool sort of concept. I think once you get familiar sort of like with the system, which is quite unique or a bit special in how you might be familiar with programming on these other these ecosystems is good. Maybe with specific regards to like data availability, that is what people are familiar with this sort of interaction with L2s, is that you can just encrypt the data on the chain, and you can have provers interact with it afterwards. But
Thank you,
okay,
Daniel.
sorry.
Thank you very much. Let's give him another big round of applause. Thank you very much, Daniel, from the Aleo protocol. You can leave it on the table. Thank you so much. All right. Really appreciate it. Again, our speakers will be around a little bit later, so if you have more technical questions, I barely understood 10% of the answer, but I'm sure you can understand more if you go and quickly have a chat with him outside. And it's nice to see hackers as well using the Aleo protocol as well for their projects, so please continue to build in the space. The hackathon is actually ongoing right now. Some of the hackers are here, some are outside working on their projects. All right, our next speaker is already getting ready. Oh, already so fast. Let me quickly give a quick introduction. But before the introduction, some reminders. So the organizer has mentioned to me, some people might be a little bit hungry a bit early this morning. So no worries, they've actually opened the lunch area downstairs, Fresco. It's on the ground floor. Look for Fresco. They've actually opened it already. So if you want to go a little bit earlier before 1 to 2 p.m., it's already open. You can go and grab something to eat there. Another quick reminder is, okay, no, actually that's the only reminder for now. Okay, thank you so much. Our next topic is from the Taiko platform, and this is a decentralized Ethereum equivalent (type 1) zkEVM. Now, I'm not a developer, so this is all a bit foreign to me, but our speaker, Keng from Taiko Labs, is going to be explaining a little bit more. Let's give Keng a big round of applause. All right, Keng, please take it away.
All right, thank you for the short introduction. So my name is Keng from Taiko. I'm doing developer relations at Taiko. Full disclaimer, so today's presentation is actually supposed to be presented by my teammate, but he couldn't come here because of his passport issues. So I'll try my best to try to deliver this keynote. So the title of today's presentation will be about multi-layer dApps. So I guess in today's like L2 landscape, there are so many L2s. There's like Polygon, Mantle, Taiko, Scroll, but there is a problem, right? Like every single layer 2 has its like separated individual ecosystem. And what if we could aggregate all of these projects together? First of all, it will solve like the liquidity issues, and also like from a user's perspective, they don't have to switch between chains to basically interact with them. And from like the developer's perspective, you don't have to redeploy like smart contracts on every like different L2, right? So with that in mind, let's continue this presentation. So right. So in today's like state of like the single of each individual L2, actually the state of each individual L2 will also eventually grow too much, and this leads to higher costs because of the storage that you have to spend, right? So eventually each L2 will might also grow to the size of like Ethereum, and gas fees will also increase accordingly. So the scaling factor of a single L2 is sort of like limited by that, right? And this diagram over here just shows like how at least how Taiko shares the state between the L1 and L2, so that you know whatever assets that you bridge from L1 to L2 is validated or not, right? So what do you want? What do we want to achieve? So we want to achieve atomic and synchronous transactions across multiple L2 chains, so it doesn't feel like it's splitting up. And I think that this is like the goal of many L2s and many super chains out there. So what does atomic and synchronous mean? So atomic means that it whether a transaction succeeds or it doesn't. For example, if for a regular Solidity smart contract, if there is a revert statement, if your functions gets reverted, every state change before that doesn't happen at all, doesn't get mined at all. And what I mean by synchronous is that it happens in a sequence. So all of the transactions between the multiple L2s happen in sequence, and there is no like wait between the two L2 transactions. Right, so the first so-called architecture that we propose to enable multi-layer dApps is the multiple L2 architecture. So in this architecture, we ask ourselves, how do I transfer a token from L2A to another L2B, right? So this is a simple bridging example. So first of all, you burn the token on L2A, you wait for the validity proof, and then you deposit into the other bridge over here, which costs like a L1 cost, it costs you to pay gas fees on L1 to actually do this bridging, right? Then from that L1, it gets bridged to your destination chain. So there's actually two transfers, which is not really efficient, and there is no. It is not atomic, and it is also it may be synchronous, but it is definitely not atomic, right? Okay, so how do we improve on this? So the next the next architecture is to use a shared bridge. So in this case, I think the general idea is that users are able to just bridge directly between two L2s, right? So in this case, how does a user transfer from one L2 to the other? First, it gets burnt on the L2A, same as before. You wait for the validity proof, and it will be actually minted directly on the L2B. But this, in this case, is asynchronous. You need to wait for the proof on L2A to be submitted first before actually before the token can be minted on L2B, right? And okay, so to solve the asynchronous issue, we try to make the shared bridge synchronous in this case. So sorry, I think this should be a shared sequencer. Yeah. So a shared sequencer will construct a super block on the L1 with a transaction on L2A and L2B. So this means like the burn function on L2A and the mint function on L2B will be proposed onto an L1 block altogether. And this is how we keep like the atomic nature and the synchronous nature of this cross-chain interaction, right? So just going through these diagrams over here. So for example, if we take like a L2A to be like this one over here, as you can see, the bridge doesn't have to go through the L1 anymore. It can just go through just bridge between the L2s directly, right? And also on this diagram over here, the atomic cross-layer transactions, but the validity rules require executing all L2s and a shared sequencer. So the shared sequencer would be in this L1 block over here. And yeah, it will probably, because you're including like both L2s transaction in the L1 block in the shared sequencer, you will probably need very fast zk proofs, very optimized zk proofs, or even some like optimism to scale this solution. So yeah, this also is together with the idea of like a multi-proof system. So perhaps we could have some blocks that are proven using validity proofs, and like maybe 100 blocks in between we use optimistic proofs. So like every 100 blocks you have like a checkpoint using validity proofs, yeah, for this infrastructure. Okay, so another way is to actually scrap the entire bridging idea altogether and use a L1 call and or L1 delegate call. So this idea is basically developers won't deploy any smart contracts on the L2. But yeah, all of the contracts will live on L1 actually. So like your Uniswap, OpenSea, everything on L1, but use L2s to submit calls or delegate calls that will be pushed onto L1. So your L2s are basically just communicating like the state change that will be reflected onto L1. And I think this will solve the problem of having to deploy contracts on every single chain, right? So I think the diagram here kind of shows gives an idea of how this might work. So on the L2, there will be a smart contract to just execute a call, or rather this L1 call, which will indicate like the address of the L1 smart contract and also the call data. So like I don't know, like a swap or whatever, and then this L1 smart contract will be included. The transaction, this whole L2 block, this request for state change will be included onto L1 block like a regular rollup, and this will actually indicate your state changes on the L1 chain. So yeah, so I think this would be probably a pretty good solution. It will be cheap and convenient to access the latest L1 data, but I don't think anyone has done this yet. So it's pretty much experimental, and if anyone could do this during the hackathon, like test out this idea, that would be great. So basically using any L2 to call L1 contract. Yeah. So, okay, so yeah, so like all other L2s, like Taiko also has like wants to have like a super chain, and we call it the Taiko singularity. So with the same concepts that we have in mind, it could be the delegate call or the shared sequencer. We want to have we want to parallelize the deployment of L2s to scale Ethereum. Yeah. So I'm pretty sure this diagram is common across most L2 super chains. Yeah. So yeah, I think that's the end of the presentation. It's pretty short. Yeah, and these are like further readings and research that contributed to this short keynote. Thank you.
Thank you very much. Really appreciate it. As you understand, your colleague could not make it, unfortunately, so it's nice of you to be able to step in and still give the presentation. Really, really appreciate it. We quickly open it to the floor. Does anybody have any questions about Taiko, about the presentation? I'm not a developer, so all of this is a little bit... Okay, we have one. Yes, we've got some developers in the audience. Just please introduce your name and then also your quick question that you want to ask. Thank you.
Hey, I'm Elias. Thanks for the presentation. I just have a question about the bridge from L2 to L2. I understood the shared sequencing. Just can you briefly explain how L2 to L2 sorry, trust minimized, like trust minimized or trustless?
Okay, so this requires like this smart contract called the bus smart contract. So it actually I don't have the code right here, but this bus contract basically indicates for every transaction on like a single L2, you have to modify your smart contract to inherit this bus so that it can transfer data to the destination chain. Yeah, but yeah, maybe I can explain more in detail. I think if you see the sample code, maybe you probably understand.
Okay.
Yeah.
Hey, sorry, the question was about the shared bridge.
Oh, the shared bridge. Okay. So like how do you? Yeah. So part of the shared bridge, it actually, it actually adapts this bus contract, but yeah, it's not here. So
Or if you have the code later, you can show it to him, perhaps after
yeah. Sorry about that.
Might be. No problem at all. Perhaps later. Some things are a little bit complicated. You can't fully put it into words. Sometimes you need that smart contract next to you. But no worries. Any last question? One more, two more? I like the term Taiko singularity. It sounds nice. Okay, let's have one more question up here. All right, please introduce your name and the question.
So thanks for your presentation. So I'm Martinet. I have a question on the I guess the synchronous with the sequencer. So you have a super sequencer right there. My question is, if we're waiting for one of the L2s and that L2 is like, let's say crashing, I'm considering this case, and how do you handle those cases? Like, because if you're waiting for all of them, then that kind of becomes like a DOS vector, if that's a requirement. So I'm just wondering, what's the solution in this case?
So like the example would be if you submitted like a bridge transaction. So if you wanted to mint a token on L2B and you already burnt token on L2A, and what if like one of the chain crashes? Okay, so I think in the shared sequencer, you include both transactions in a single block on L1. So if either transaction doesn't happen on either chain, the block will be just like reverted on L1. Yeah.
Okay, hope that answers the question. If not, you can always find Keng and ask more questions after this. Let's give him another warm round of applause. Thank you very much, Keng. Appreciate you taking your time to explain about the Taiko Labs. And of course, they're still available outside. You can go and check out later on. All right. Without further ado, another quick reminder for those of you who just walked into the hall just now. If you're hungry, I heard that the lunchroom is actually open a bit early. So you can go and grab a bite if you need to, or if you're a little bit hungry, you can go down. It's on ground floor. It's called Fresco. All right. We're going to continue our talks about zkEVM. So today, if you've seen our talks, many of them about zkEVMs, many of them about L2s, optimizing and stuff like that. So if you're here to learn about that, you're in the right space. There are also other simultaneous talks which are going on. Feel free to go and check them out as well. Now, our next speaker is from another project called Kakarot. This is a modular zkEVM written in Cairo, I believe also deployed on Starknet, if I'm not mistaken. And we're going to be hearing from the co-founder himself, Danilo. Danilo Kim is here with us, and he's going to be explaining a little bit more about the Kakarot zkEVM. Okay, we'll just let them set everything up. Make sure you got your clicker ready. All right. And we're getting our slides ready as well. Okay, just give us a minute, Danilo. We're just getting it ready for you. Fantastic. Danilo, where are you from? From Brazil. Fantastic. I hope to visit Brazil next year. You've got your microphone over there? Yes. All right.
Hello.
All right, ladies and gentlemen, let's give him a big, big round of applause as we welcome Danilo from Kakarot ZVM, zkEVM, how and why Kakarot. I would love to learn more.
Hello, my name is Danilo, and today I'll talk a little bit about Kakarot, just to share the story, because I think I've never talked about Kakarot in Malaysia. And also, we'll explore a little bit of how zkEVMs can go beyond L2s. Right now, the main narrative is, oh, zkEVMs are L2s, but definitely there's a lot more than just L2s from how zk can be used on Ethereum. So, yes, so first, who am I? I'm Danilo, I'm from Brazil, I'm a business graduate. I've been in crypto since 2017, and last year I co-founded Kakarot together with Elias, Clemon, and Mentor, who are not here. And I'm really glad and grateful to have the opportunity to be talking in stages like this. And before we start, how many people here are developers? Okay. How many are participating in the hackathon? Okay, nice. I'm just asking because Kakarot was a project that was born almost like a year ago in a hackathon. So yeah, and we've grown super fast, and we had the opportunity to be here. And so really, I really incentivize you to try your best doing hackathons. So why Kakarot and why zkEVMs? I'm gonna go a little bit back. Ethereum was published, the white paper of Ethereum was published in 2013 by Vitalik, who at the time was doing, writing articles on the Bitcoin news. And in 2015, they launched. So Ethereum raised $80 million, and then after gathering an incredible amount of people, smart people, they launched in 2015. Everyone was very excited because at the time, most of the people were looking for app chain specific blockchain. So there was a lot of blockchains being developed, but oh, a blockchain specific for this, a blockchain specific for that. And then Vitalik came and said, hey, why not create a blockchain where you can build any app that you want? But we know, I guess for everyone who have been here since more than 2 years ago, Ethereum have reached its limit, which is actually a very good news. It means Web3 is growing, right? Web3 have really reached an audience much bigger than we expected. In the beginning, the transaction fees were very cheap, but in 2021, we reached a peak of $71 per transaction, and that's the average, right? So I'm sure if you are a DeFi enthusiast, you have paid a few $100s in gas. And so, and a lot of the things that, for a lot of the solutions that Ethereum was looking, actually Ethereum was looking into solutions before the peak. So since 2016, since 2017, actually like CryptoKitties first showed how Ethereum had these limitations. And one of the technologies that would fit with Web3 the most were zero-knowledge proofs. And zero-knowledge proofs, they released papers in 1985, but only in the last years, it went from articles, like math articles, to actually production-ready projects. And there's a lot of different zero-knowledge proofs. Today, I will talk, just to give a little brief about the two main ones, which are the zk-SNARKs and zk-STARKs. And who here knows about zero-knowledge proofs or knew about zero-knowledge proofs before? Okay, have a good audience. So SNARKs stands for Zero Knowledge, Succinct, Non-Interactive Argument of Knowledge. And STARK stands for Zero Knowledge, Scalable, Transparent Argument of Knowledge. Each of these acronyms they are like one property of snarks and starks. But here I would just talk a little bit about the zero-knowledge aspect, the succinct aspect, and the zero-knowledge aspect from the starks, and the scalable and transparent aspect. So in snarks, the zero-knowledge means that you can prove things without revealing anything from what you're trying to prove. So any information, so you're trying to prove your age, you can prove your age mathematically without sharing what's your age. And in Web3, we see that's great because right now everything is public, which has its benefits, but it definitely limits us to build some applications. And succinctness, which is the main topic for today, is basically you can prove 10, like a computation of 10 with 1, right? Like, so you compute, you can compute a lot of transactions and prove all these transactions in 1. And that's what actually zkEVM is. Like the word zkEVM is a bit weird because we don't use the zero-knowledge aspect. We just use the succinct aspect. There's no privacy yet on zkEVM's L2s, at least for the ones that I know. But we still use the name. I think it feels smart. And for Starks, the difference is that in Starks, the scalable aspect means that when you have bigger witness, when you're trying to prove much bigger stuffs, it can become cheaper than snarks. And the transparent aspect is that in snarks, you need something called trusted setup. So basically, there's like this private key of your circuit that if someone knows it, they can hack it. In snarks, there's no such as private keys. And basically, trusted setups like the ceremony of a trusted setup is usually really big. We are having one for proto-dank sharding, and it went for 2 months. Like you need to be very, very secure because if anyone can hack it, then the whole system is gone. So there is this trust assumption that the trusted setup was done correctly. In Starks, you don't need that. And so, okay, we have Ethereum. It went well. We have its limits. We know that zk is we read the papers and we see, oh, zk might be able to help Web3 in some way. And how can we do it? There was a lot of researches, and one of the first things that came to mind was, okay, let's scale Ethereum, right? We can use zk to scale. We can start to compute things off-chain, which is not executing on Ethereum L1, and then just verify on L1. So basically, you execute all your transactions. You execute thousands of transactions outside of Ethereum L1. And then you just verify the state transition on Ethereum L1. And what this allows you to do is, one, you don't need to pay all the execution fees on L1. And two, you still are as safe as Ethereum L1. You inherit the security of Ethereum, which actually, that's one of the most important aspects, to have the security of thousands of nodes with hundreds of thousands of people. I don't know if hundreds of thousands, but dozens of thousands of people backing it up to make it resilient and secure. So, and what is Kakarot zkEVM in this scope, right? zk is not the only way to have L2s. We have optimistic rollups. We have zk rollups. The difference is that optimistic rollups, they basically say, okay, trust me. And if in 1 week there is nothing wrong, this is finalized. zk rollups is fully math, right? And for the long run, I guess we want to trust more math than human trust. That's what made Web3, right? So Kakarot zkEVM is an EVM written in Cairo. Cairo is a programming language that you compile to COSM, which is Cairo assembly, that can generate Stark proofs. So like I mentioned before, Starks is a little bit different than Snarks, and in Starks, the bigger your computation, the cheaper it gets, and also it's transparent, so we don't rely on any trusted setup. And Kakarot can be used as a L2 or L3, right? In the beginning, I'm gonna get into the details, but in the beginning, we were planning as to become a smart contract on Starknet and L3, but things might change as we go. And Starks have been, one of the things in cryptography is that the longer it has been deployed, the safer it is considered. Because basically it says, okay, there is this assumption that haven't been broken for 10 years. There is this other assumption that haven't been broken for 5 years. So even though both haven't been broken, the 10 years one is considered safer than the 5 years one because it means people had a longer time to try to hack it, but they weren't able to. And Starks, it's one of the first ones to be in production with transacting a lot of transactions and handling a lot of money actually, and they transacted more than almost $1 trillion worth of transaction. So yeah, I think it's a very good news for Kakarot. But okay, now we'll share a little bit how Kakarot was born. We know Ethereum. We want to tackle these limitations that we have. zk is a good idea, and then where did Kakarot came from? So actually it started from a tweet. It was a tweet from Shahar. Shahar is the creator of Cairo, and he's from Starkware. And last year, July, he tweeted, oh, why not build a zkEVM on top of Cairo? Like I said, Cairo is a programming language that compiles to COSM, then that generates Stark proofs. And he said he was already working on a proof of concept, but it seems that Abdel has his doubts. Who Abdel? He will appear later in the story. And he mentions like, oh, I've never seen that proof of concept, so it might be a legend. You never know. And so after this tweet, in October 2022, we had at that time, Starknet ecosystem was a bit smaller than it is today. And we gathered all the 100 devs that were in the Starknet ecosystem, and we did a hacker house. And during that hacker house, there was a lot of project proposals. And at that time, Abdel had just joined Starkware, and he was leading the exploration team. So he started an open source project, which was based on Shahar's tweet to build a zkEVM in Cairo. And this was a conjecture together from the exploration team and OnlyDust. And actually, so Kakarot started fully as an open source project by the community for a hackathon. And this is just one funny story I like to share is during the hackathon, we were building all the opcodes in Cairo. We were trying to get a simple counter contract for the demo. We had at least around 1 week at the time. And there's a difference between EVM addresses and Starknet addresses. EVM, they only use the first 20 bytes, if I'm not mistaken. And so we had to pad, we had to do this conversion. And we did that, okay, in Kakarot, all the contracts for the hackathon will start with OX Abdel. So for a while, all the contracts in Kakarot, they started with OX Abdel. This was for the hackathon, of course, this is not the case anymore. But it was really interesting because this really helped us on the last day. We were having a bug. And then we like 3 a.m., the delivery is at 12. We have a bug. We don't know how to solve it. Like, okay, what is happening? What is happening? Our brain is not working so well anymore. But then we look at, hey, for some reason, this contract is not starting with OX Abdel. What is happening? And then we found the bug because the contract didn't have OX Abdel. So it was really interesting to, it was a really fun moment also. And then after that, we were able to actually deploy the contract and do stuff. And since then, we had many contributors. And the reason why we were able to, and actually in 2 months and in 20 days, we were able to implement all the opcodes. And the reason why is because of Cairo. In Kakarot, we are not building the circuits themselves. We are just writing in our normal programming language, not so normal, it's a bit harder than a normal programming language, but we don't need to write in circuits, not just only us, but any contributor. So what is allowed is that the barrier of entry to have people contributing to Kakarot zkEVM was much lower than the barrier entry of you trying to implement an opcode in Halo 2 or other zk secrets. So this allowed us to have many contributors. Most of them are not cryptographers. Most of them have never written secrets, but they could write Cairo. And I think this allowed us to move really, really fast. I remember that when we got 142 opcodes equivalents, it was a big milestone because we had started in 2 months, we had working and we had a ERC20, ERC721, and a lot of transactions already working in Kakarot. And so just to share a little bit, I think this is one of the benefits we have is that because we are partnered with Starkware, all the cryptography, amazing cryptography that they've been doing since 2017, early even before, we just trust them and we focus on building the EVM itself, not having to worry too much about, of course we worry, but not too much about the cryptography aspect. And as Kakarot started to grow a lot, so October we had the hackathon, December, we had all the opcode equivalents. We started to get so much interest, and that in Q1 of 2023, Q1 of this year, we decided, okay, let's incubate, let's turn it to a real project, let's bring this much further than just hackathon project. So today, we have integrated MetaMask, Remix, Foundry, Ether.js. Right now, you can run a Kakarot node, and not for public internally. We are still doing a lot of tests. But basically, I think this was achieved in July this year. So basically, in 10 months, we had a zkEVM that you could just like add your RPC on MetaMask or add your RPC on Foundry, Remix, and it would just work out of the box. No change needed for the user or for the developer. It wouldn't change anything. We are also integrating and testing other EVM toolings as our goal is to be able to have a zkEVM where you don't have to touch anything and you already have your zkEVM. You just use as any other sidechain. So currently we are focusing on testing to make sure that we can release a good testnet and a good mainnet. And we are running the Hive and ETHKL tests, which basically are tests made by Ethereum Foundation that they have a lot of edge cases. And as we started to run them, we started to find some issues, even though the main cases in Kakarot was already working, like ERC20, ERC721. We noticed that our implementation had some issues after running the edge cases of the test. And currently, we are doing our best to fix all the issues to soon release testnet. So, okay, I talked about L2s, I talked about Kakarot story. We are releasing our testnet and mainnet. What's next, right? Like, what could be more beyond zkEVM? If I believe there's much more, and we'll be sharing a little bit now. So, beyond zkEVMs as L2, there are some aspects that is already known. Right? These things are already, like, if you look for it, you already see some people mentioning about it. But these are some of the benefits that zk can bring to the Web3 space besides just scaling L2s. Number one is layer one proving. Number two is app chains interoperability and app chains composability. I'll go into details of each of them. So L1 proving. This was a quote from Vitalik. zkEVMs are not just for rollups. We want to use them to verify execution on layer one as well. And if zkEVMs can prove layer ones, this will decrease by a lot the barrier for people to run their own node, which means you'll become a lot more decentralized, a lot more resilient, and the UX itself for Web3 will increase dramatically. Nowadays, I guess, how many, like, does anyone here runs a node, Ethereum node? I don't. Okay, 2. I guess if you had zkEVMs later on proving, anyone would be able to run from their phone. So anyone doing this presentation, technically TM. But the idea is that in the start of this presentation, you'll be able to download an application, start running a node, and by the end of this presentation, you would already have an Ethereum node running locally. So this will scale a lot the centralization and the resilience of the ecosystem. And talking about, looking at how zkEVMs can prove L1s, now let's take a step back and look how currently Ethereum has a multi-client philosophy. The multi-client philosophy is basically that it is better for the ecosystem to have more than one client node than to have only one, because there's much less risk. And here it is a graph that was shared on one of Vitalik's posts, saying that, okay, by the numbers of clients, today we have Get, Wrath, Nethermind, and some others, the failure of the risk of the system. And just to share a little bit more about this failure risk, in 2010, there was a guy who were able to mint 184 billion, or was million. I think maybe I might have miswritten or not. Bitcoins because of a client overflow issue. At that time, there was only one client, and actually there was, like, at that time, Bitcoin, you couldn't convert Bitcoin to cash, right? There was no bridges, no exchanges. So this wasn't a huge issue. So Satoshi and the team, they fixed it, and after some blocks, it was already fixed. But this shows the risk of having one client and having the bug in one client. Prior to this bug, there was already 4 bugs on Bitcoin, and even today there have been found more than 40. So if you have only one client, you are very susceptible to having bugs which can literally kill the ecosystem. And also another thing, the importance of having multi-client is that if only one team runs the clients, they have too much power in the ecosystem. They can start dictating how they want the protocol to be developed, and they can also start bargaining and threatening people, okay, if you don't do this, I will stop developing. We are seeing this happening in some ecosystem where, because only a few people have the technical knowledge, they end up being able to bargain. So L1 also needs multiple provers, not only one. So right now we are seeing, okay, there is zk Sync, there is Polygon zkEVM, there is Kakarot. It's not that, oh, they are all competitors. As of L2, maybe. But for the resilience and growth on the centralization of the ecosystem, it is important that we have all these different provers so that if one of them have issues, we can rely on others and still have all the benefits of proving L1. So that's one thing that we really believe in Kakarot, is that, oh, we don't see everyone as a competition, but as partners who are making that technologies will make Ethereum more resilient. The second aspect of, besides L1 proving, is interoperability, which basically is you can, one chain can read data from other chains. I think Taiko was mentioning a little bit about it. And right now, there are 2 paths that you can take. One is you have one L1 that holds all the data, and the L2s communicate through that L1. And so basically, I have an example. So this was from an article as well. But basically, let's say you have a data on Linea that you want to access on Kakarot. Linea would need to submit the proof to Ethereum L1, and then Kakarot would read the proof from Kakarot, from L1, and then with that, Kakarot would have proved data from Linea in Kakarot. And another way, so there are 2 ways to do it. One is, actually the previous one is using zk, like you're using zk to put on L1 and or Merkle roots to verify on Kakarot. Another way is to have you can add precompiles in Kakarot, and so Linea updates to Ethereum L1, and Kakarot just with the precompile can read directly from L1. Another aspect of interoperability is chain-to-chain. For example, Linear, instead of settling on Kakarot, on L1 can settle directly on Kakarot, but there's a risk. Right now, all the L2s, they are centralized sequencers, so you'll be losing the security aspect. Besides interoperability, composability is something that we might be seeing soon. And also, it's thanks to zk that we might be able to do this. And basically, the difference is that you can call other chains contracts from your own chain. So imagine a cross-chain flash loan. That would summarize composability. So these are the three aspects that I believe zk can bring besides just L2s. L1 proving interoperability, composability of the Web3 ecosystem. And right now, Kakarot is looking to launch testnet, launch mainnet, develop L1 proving technology so we can be part of this resilience and decentralization, and also explore app chains interoperability and composability. So yeah, hope it was useful. And
All right, thank you very much, Danilo. I'm sure very, very useful, of course, for especially those developers in the audience. We'll quickly open it up for one or two quick questions if anybody has something they want to ask about the Kakarot EVM built on Cairo and Starknet. Oh, we got one question here. Let me pass you a microphone. Just please introduce your name and also your question. Yes.
Hi, Brendan here. Question is like, when you said that it started from a tweet and it's like a challenge, okay, let's build a zkEVM using Cairo. And there are other implementations that do so, just using base Rust. Now, if you hadn't started from that, like sort of retrospectively, like what were the advantages of building on Cairo versus, directly using for example, Rust?
Yeah, today you can use with Rust thanks to RISC-0. But basically the main advantage, I think, in developing in Cairo is how much easier it is than developing in Halo 2 or other proving systems. Most of the other zk teams, at least the bigger ones, they are working both on developing their circuits and also the EVM on top of their circuits. So they're developing the circuits. They're also creating their own language because it must be really hard to debug. I think debugging is one of the main aspects to debug circuits directly. So they have their own intermediate language, and then they are all writing on their intermediate language. We are already working directly with the intermediate language that have been designed to be mass used by people. So we have speed. We have it's easier to onboard people to contribute, to find people who can help us on, and yeah, I would say that's the two main advantages.
Okay, thank you for the question. Thank you for the answer. Any last question? You can just raise your hand. I'll pass you the mic. If not, let's give Mr. Danilo a big round. Oh, we have one more question? Okay, sorry, I didn't see your hand. Okay, one last question. Before we close the session, please introduce your name and your question. Thank you.
Hi, so my name is Weihap, or you can call me Aaron. It's a dumb question, but why Kakarot is being named Kakarot?
Why is it being named Kakarot?
It was actually named by Abdel. And what Abdel mentioned is there are two stories that I think Kakarot could be like something about Cairo. I don't remember this story exactly. Like, oh, it's acronym for Cairo. And the second one, which I think this is the main one, is that Abdel really values the mindset of anime, like the values and the mindset of, for example, Goku, or like always trying to improve himself and trying to battle. And you will see that most of the Starknet exploration teams' names are based on animes. And the idea is that, oh, like we inspire ourselves from the mindset of these anime characters, which I'm a big fan of it. So if you can have the same mindset as a Goku, naive, hardworking, focused, and always improving, like there's nothing that can go wrong. So yeah.
Okay, interesting. Thank you very much, Danilo. Let's give him a big round of applause. Really appreciate you explaining a little bit more about Kakarot. Maybe one day we can have an Attack on Titan zkEVM, Naruto zkEVM, who knows, right? Inspiration can come from anywhere, whether it's an anime or elsewhere. All right. Ladies and gentlemen, our next speaker is a very interesting speaker because many of the projects, the protocols here are actually built on this zkEVM, right? we're actually going to be listening from the guy who built the code. So everybody is taking his code and building the protocol. So this guy is a really, really big name. You can see online, his name is in the same sentence as Vitalik Buterin. So Chih, Cheng, Liang, he's from the PSE Ethereum Foundation. So very, very interesting. And of course, this session is a little bit more technical. So please feel free to stay back if you're a developer. And if you're not, and it's a little bit beyond your knowledge, don't worry. I think just listening also helps a long way, right? It helps you get a little bit more involved in the developing infrastructure of zkEVM. So he's going to be talking about something called Lookup, and he's going to be explaining it. You can see more people coming in already, I think, because they know he's speaking. So please come in. Please take your seats. This is one of the rare opportunities we get to listen to an OG from the zkEVM infrastructure who has created the code that allows other protocols to go and make their projects. Okay, so that's quite interesting when we can get a look into his mind. All right, please put your hands together and let's welcome CC Liang.
Thank you. That's a very nice introduction, and thank you for having me.
You're very welcome. Thank you.
So today, the topic is a little bit more technical, and I'll be talking about Lookup protocol. It is a very exciting cryptography technology that's been improved over the last year. Like, if you see the paper, like they're publishing months by months, and now we are already reaching some kind of lookup singularity. But most of these talks or introductions were like more research focused. And today I'm going to talk about some engineering side, like when you are a circuit developers, how do you like actually use lookups in your how-to circuit code? As Danilo said, like most of zkEVM team, we use a very custom languages, and there are some detail in it. So for me, I'm a member of Privacy and Scaling Exploration, and we're building a zkEVM community version. The repo is zkEVM circuits, and we're building a succinct proof of EVM execution. We're returning Hello2, and we're targeting L1 use case, specifically zkEVM-like client. So before we talk about Lookup, let's see how the proving system work, and also how to lay out the circuit. So we have the setup time, where we need to define some constraints. You, as a developers, you kind of define this Sudoku board puzzle, which defines some rules that the solution must satisfy. And then we compile this circuit into proving keys and verifying keys. And we send a verifying key to the verifier and proving key to the prover. And in the proving time, the prover has to fill in the computation trace into this Sudoku board. So everything happened in the proving time, right in the red, like handwritten font. And then the prover generate a proof from this Sudoku board using the proving key. And the proof is just a list of bytes. But this list of bytes will be sent to the verifier, who use the verifying key to verify the proof and determine if the proof is correct or not. And then how do we define the rule of this Sudoku board? Like what value filled into the Sudoku board is correct or incorrect? So in Hello2, we kind of defined the circuit in a grid. So a cell in a grid is a finite field number. It's a very big integer, and it wraps over. So it's finite field arithmetics. And the rows are kept. They have a maximum the maximum like 2 to the 16 or 2 to the 20 rows determined by the setup parameter you use. But they are free. Try to use as much row as you can. And for columns, they add additional cost and verifying cost. So if you need more computations, you need more cells to fill in values, and and if you're running out of space, you add more columns. Try to think this is a truck and like loading a bunch of computations. And now there are different kinds of columns. So if we determine the Sudoku puzzle with this fixed column, which is determined at setup time, and the values are filled in the setup time. So I used this black font to represent the fixed column numbers, and also use the this blue-purple color encoding for it. And this is determined at setup time. We call it fixed columns. And then the advice column is for the prover to fill in the proving time values into these cells. And they are determined at the proving time, and they are visible to the prover, and the verifier doesn't have the access to these values. And the last one is the instance column. So those values are both visible to the prover and the verifier. So to recap, when we fill in the computation trace, the prover filled in the advice column and the instance column and generate a proof. And the verifier can see the information on the fixed column and the instance column and verify the proof. So for example, if you're writing a Tornado Cash application, you might need to put your public inputs on the instance columns. There might be Merkle roots, and the prover witnessed secrets and Merkle path inside the advice columns. So now we can express the constraints. How do we determine the rules are correct or not? There are 3 ways you can define the constraints in the circuit. One is custom gates, one is lookup, and the last one is copy constraint. But in this talk, we'll focus on lookups. So what is lookups? For a simple example, let's say the first cell of this column, prover can fill in every numbers, but let's call this number x. And we want to constrain this x to be either 1, 3, 4, or 11. Like you can choose like arbitrary numbers you want, but we just want to constrain that in either this 4. So as a circuit developer, you fill in these 4 numbers in the fixed columns, and then we define the lookup constraint as the cells to look up and the table columns to look up for. So what happened in the lookup protocol is, for example, the prover filled in 3 in the advice column, and the lookup will check if 3 is inside this lookup table. So as you can see, 3 is inside the table. So this circuit is satisfied. And for another example, if the prover filled in number 11 in the first cell, and then the lookup scan down the fixed column, and then it finds 11 is indeed in the column, then this is also satisfied. But if the prover filled in number 100, and then you scan down the lookup table, but there's no 100 in the table, so this is unsatisfied. So it is invalid proof if you send a proof to the verifier. This proof will be rejected. So that's how lookup table works. You fill in the all the possible value in the table column. So one simple use case, which is very common, is a range check. So we can check if x less than equal to a and greater or equal to 0. If you use other constraints to program this will be very costly and very complicated. But with the lookup, you just fill in 0 to a into this table, and then it's done. Like you can, and you can constrain like multiple different cells with the same cost. And the other very common use case is the bitwise operation. So bitwise operation is something like AND or XOR, something very, very common in your first programming language, but it's very hard to do in a circuit because the circuit only allows you to do additions and multiplications. And let's say we have 3 variables, x, y, and z, each are 1 bit. For the lookup, you just put in the whole truth table inside the table columns. So the x will look up to the first column, y look up to the second column, and z look up the third column. And there have to be bitwise operation to satisfy the whole the constraint. And here the more advanced use case, which we use in our zkEVM circuit all the time, is that it allows you to create an interface between different circuits. So we use lookup table as a kind of bridge to glue different circuits together. So each circuit can focus on their own core application logic. For example, we have the Merkle tree circuit. This is dedicated to the tree logic, and it needs catch-up hash functions to compute the parent nodes, but we don't need to write the whole catch-up hash function inside the Merkle tree circuit because catch-up hash function is a very complicated circuit. Instead, we create a lookup table which we filled in the catch-up input bytes to the catch-up output bytes. And then we use a catch-up circuit to verify the correctness of the table contents. And then for the Merkle tree circuit, it just look up to the table and find the corresponding output to the corresponding input. So the Merkle tree circuit can fully trust this table, and but we verify the table using the catch-up circuit. So this creates a good separate concern of different circuits. And for the future, or maybe it's we're getting close to that. Like, what if we can create a bitwise operation table that can handle many bits? Like, for example, in the previous example, the x, y, z, they are 1 bit. But what if we can do 32 bits? The table size would increase greatly to a degree that's not feasible in the current how-to setup. If you think how-to row has like maximum like 2 to the 20 rows, but like if you have 32 bits, like x would be, it would need 2 to the 32, and y need 2 to the 32, and the truth table would have a 2 to the 64. Like it's very crazy big. So, but if we can do that, then we'll have this what Barry Whitehead called it lookup singularity, which we no longer need to program circuit in like custom gates and like all the crazy polynomials and like additions and multiplication of finite fields. We just use the regular like good old days like bitwise operations, 32 bits arithmetics. You can write it the circuit like your old programs, and we can forget everything about like writing like finite field arithmetics. And this year there is a new paper called Unlock the Lookup Singularity with Lasso by Srinath Sethi, Justin Fowler, and Raul Wabi. So the idea of the paper is that if the lookup table fit into a structure, then we don't have to commit the lookup table and send that to the parallel verifier, because like the cost of the lookup is like you need to pre-process it, and then you need to commit it, and you have to do your trusted setup, and which takes a very long time. But if it fits some structures, you don't you no longer need to like commit and set up and send it somewhere. Like you can use the lookup table directly. So yeah, that's my talk, and I put this picture because like it's the one I used in the previous like zk introduction talk, and you see if you can find a cat among these dogs. Thank you so much.
Thank you. Let's give him a big round of applause. Thank you, CC. You said there's a cat there, is it? Where?
Yeah, there's a cat.
I'm looking for it.
It's an illustration from Yashin.
Anybody found the cat?
Yeah.
Oh, you found the cat? Okay, don't tell. Need a minute.
Yeah.
So if I can find the cat, I can become a zkEVM developer?
Yeah.
I hope so. I hope so. I wish. Okay, thank you very much, CC. I'll open the floor for questions. If anybody has any questions about Lookup, you want to ask? Okay, yeah, I got one over there. I'll pass you the mic. Give me a second. Okay. Here we go. You're very welcome.
Hey, my name is Elias. So I heard a lot about Lookup, but never understood. So thank you today. Now I understand.
Thank you so much.
Maybe I have a dumb question, so maybe there's a simple answer. But for example, in Cairo, we sometimes use rain check to check that you're less than a U128.
Yeah.
So how would you do it with your limitation of 2 to the power 16?
Yes, so that's a very good question. So for 1 to the 8, you have to break it down. Like, let's say if your lookup can process maybe 8 bits or 16 bits of bitwise operations, and you can break down your 128 bits integer value into like, how many? 8. Yeah, 8 chunks. So, and you do the bitwise operation for each 8 chunks, and then you assemble the 8 chunks results together using, you multiply them by like 2 to the 8 and 2 to the 16, and then you sum them up together again. So that's how you do the big.
I hope that answers your question. My brain is slowly melting. I hope I'm not alone. Anybody else with a question? I thought someone raised their hand at the back. If anybody else, just raise your hand. No question is too small or too big. Yeah. I always tell my students there are no such thing as stupid questions, only stupid politicians. All right, it's a bit about technical. It is quite technical. I'm not a developer myself. I'm just learning a little bit here and there. Oh, we got one? One more. We got one here, and then I'll do one last one with you. Yeah, we got a bit of extra time before 1 p.m., so go ahead.
Yeah. Well, thanks for the awesome presentation, the awesome illustration by Yashin. But yeah, I actually had a question on the interface part. So, like, how large is the lookup table for that one? And because I'm looking at the input and output. That's like input for KCHAC is, well, you can put in anything, right? So I'm curious about that.
Exactly. So I kind of cheated here a little bit. So for KCHAC input, you actually have to. The input could be like infinitely long, right? And so there's a limit for that. And in KCHAC, it kind of have 64 bits a word, and you have to split your input into bytes, and then like fill them down, and the output is kind of like 4 words, and then so the output has actually a lot of gaps in this column, and the input you can use the whole circuit just to do one Kachak, or like you can if your input is very big, but if your input is very small, you can do many. And we have to design the circuit in a state transition way. So you could have like this is the first Kachak, and then you continue to absorb the inputs, and then finalize, we generate output, and the next input absorb, and until the end. So yeah, to sum up, it's like a state transition trick, and then to try to take the catch-up for different input size. Yeah.
Thank you.
You're welcome.
All right.
That's
Thank
a good
you.
question.
Good question. I didn't understand it, but it's good. You want to ask something else? Okay. One day, my dream, CC, is that I'll become smart enough to understand all of this. One day.
I just have a question on benchmarks, like how for something, just I don't know, proving, it could be a block because we've been talking about zkEVMs, could be proving, I don't know, just inclusion. How well does a lookup perform compared to normal, I don't know, polynomial constraints?
Yeah, that's a very good question, and I don't have a good answer for this one. Like, we know like one lookup is kind of, it takes like three times more cost than a custom gate, but I don't have a very good sense of the benchmark so far. Yeah.
No worries. Maybe in the future you might have a good sense of it. Once there's more development on it. Ladies and gentlemen, let's give CC Liang a big round of applause.
Thank you so much.
Right, it's an honor to have you with us. One of the true OGs in the development space of zkEVMs. All right, and I'm sure he'll be around later as well if you want to chat with him and ask more technical questions. Oops, what happened? Careful. All right, if you want to chat with him and ask more technical questions later on, I'm sure he'll be around for questions later, as with all our speakers earlier as well. All right, ladies and gentlemen, we're actually going to have a lunch break, and the lunch break is just 1 hour from 1 p.m. already. Should be, yeah, it's going to be 1 p.m. in 5 minutes. So please, I welcome all of you downstairs to lunch. Once again, a reminder, we are slightly over capacity. So if it's full already and you can't find a seat, don't worry. There are a lot of other restaurants very nearby within 5-10 minute walking distance. Please come back here at 2 p.m. sharp. We're going to be having our next few sessions, and we've also got a panel session as well on zkEVM and development. So please don't miss out on that. I'll see you guys later here at 2 p.m. All right? Please go outside, chit-chat, network with some other booths, and go and collect all your swags, okay? Every booth has got some swags. Please go and get some swags from outside, okay? I'll see you guys at 2 p.m. Thank you very much, everybody. See you soon.